Hello, so in this video we will talk about tree traversal. So what does traversal mean? Traversal means that if you have a tree like this, see here, if you have a tree like this, in which order are you going to visit this tree? So in first and which node then and which node then and so on. So there are three main methods. There are more methods, but in this video we'll talk about three methods. So one is pre-order, then is in order, and then is post order. So all of them are defined recursively. So let's see pre-order definition. So pre-order definition goes like this, that if the tree T consists of only the root, then R is the pre-order traversal of T. So it means that if there is a tree in which there is only one root and nothing else, so that root itself comprise of the pre-order traversal. Okay, so then what next? So what if T does not contain only the root? It has some subtrees as well. So then it has a root R and subtrees T1, T2 up to Tn are the subtrees of rooted at R from left to right. Then the pre-order traversal comprises of visiting R followed by T1 in pre-order, then T2 in pre-order, and lastly and so on, and lastly in Tn in pre-order. Okay, so we traverse all these subtrees using pre-order. So now note that this is a recursive definition here. When we stop when we have only one root, uh, when we have a tree with only one root. So let's see the example before we define in order and post order. So let's see the example of this guy. Now we have this kind of a tree here. Now we have to do what? We have to say if tree consists of only one root, then R is the pre-order traversal of. So does it contain only one root for A? No, it contains some subtrees as well. So we have one subtree rooted at B and one subtree rooted at J. So what do? We say pre-order. We say first of all we visit A. Then we visit tree rooted at B. Then we visit tree rooted at J. Okay. Now tree A is already there. So I'll just copy A. For tree rooted at B, again we have to use pre-order traversals. So what is the root? B. And then tree rooted at C, so I'll say tree at C, and tree at D. What about tree rooted at J? We have J first, then we have tree rooted at K, then tree rooted at L, and then tree rooted at M. Okay, so now what? Now we have A and B already there. Now tree rooted at C is just one root, so C. So therefore we have this stopping condition here. Now tree rooted at D should have tree at E. Sorry. So tree rooted at D should have D first, then T at E, then T at F. Okay, then J is just J. Tree rooted at K is, since K is just a root, so we have K. Then L, tree rooted at L has only one root, so L. And tree rooted at M should be M, Tn, and To. So then A, B, C, D. Tree rooted at E, so E is root itself, so we have E. Tree rooted at F, so we have F, then we have Tg, Th, and Ti, and we have J, K, L, M, and Tn is just N, and To is O, and tree rooted at P. And then we see G, H, I, and P all are roots themselves without any subtrees. So we just copy them. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, and P. So this is my pre-order traversal of this guy. Okay, now note that coincidentally this is alphabetical order here. Okay, okay, okay. So now let's talk about in-order traversal. So in-order traversal is, we again, the first condition is, the stopping condition is the same, that if we have just one route, the route is itself is in-order traversal. Okay, so and then if we have T1, T2 up to Tn are subtrees rooted at R from left to right, then the pre-order traversal comprises of visiting the first leftmost subtree, then the root, then all the right, uh, all the other subtrees from left to right. Okay, so visiting T1 in order, followed by root in order, and then T2 in order. So this is not needed. Root in order means that just root. Okay, so then T2 in order, and lastly Tn in order. Okay, so let's do the same thing with in order traversal. Okay, so first of all we have T of B, then we have A, then we have T of J. This is my first step. First step is we traverse tree rooted at B, then we have A, then tree rooted at J. So tree rooted at B is, so we have for T of B we have T of C, B, and T of D. For A we have just A. For T of J we have T of K, J, T of L, T of L, and T of M. Okay. For T of C, C is the root itself. So we have C. Then we have B already there. T of D, D is T of E, D, and T of F. A. For K, we have just the K is just the root itself, so K. J is there. L is just the root itself, so L is there. For M, we will say T of N, M, and T of O. Okay, so we have C, B. So T of E is just the root, E. So D, T of F is what? T of G, F, T of H, and T of I. Then we have A, K, J, L. T of N is just the root, N, and then M. T of O is what? There's no left subtree, so O and T of P. So T of P is just P, T of G, H, and I are just G, H, and I respectively because they are roots themselves. So we have C, B, E, D, G, F, H, I, A, K, J, L, N, N, M, O, and P. So this is my in order traversal. Okay, so now let's go through our pre-order, post-order traversal. So post-order traversal, again, the first condition is still the same. That if it is we have just the root, we have just the root as the pre-order post-order traversal. But if we have subtrees T1, T2 up to Tn, then what we do, post-order. This is post-order. So post-order traversal comprises of visiting T1 in post-order, following by T2 in post-order, and so on until visiting Tn in post-order, and lastly R. Okay, so again, it's a recursive definition. So we stop when we have only one root in the tree. Okay, so then again, this tree we talk about. So first of all, we will have T of B and T of J and A. Then for T of B, we will have T of C, T of D, and then B. For T of J, we will have T of K, T of L, T of M, and J. And then we have A. Okay, then T of C is just the root. Okay, so T of C is just C. So for T of D, we will say T of E, T of F, and D. And then we have B itself. For T of K, K is just the root itself, so K. T of L is the same. For M, we'll say T of N, T of O, and M. And J and A are as it is. Okay. Then we have C. T of E is what? E is just the root, so E. F. T of F is what? T of G, T of H, T of I, and F. And then we have B, K, L. T of N is what? N, because it's just one root over there. T of O is what? So T of O is T of P and O. And then we have M. Then we have J. And then we have A. Then G, H, I are just the roots themselves, right? And P is still also just the root. So we just say C, E, G, H, I, F, B, K, L, N, P, O, M, J, A. Okay. So we have C, E, G, H. So I forgot a D here. So now note that this is quite intuitive. So once you have the definition, you just have to keep following the definition, and you will get your post order, in order, or pre-order traversal. And it's very easy to program in the computer also. So if you have these definitions, and if you have a data structure called tree, and you have some left subtree and right subtrees, you can easily program this kind of recursion in any programming language. And it's widely available. I mean, you can see the algorithms in textbooks as well, but it's important to see how does it work by working on it by hand. So this is it about tree traversals. Hope it was easy to understand, and thanks for watching. Hope you liked the video.